dramatic change in the cloud area. So now the multiple cloud, hybrid cloud has already become the de facto standard topology for user enterprise customer. And also we see there's a threat that people are using more and more SaaS application, especially Microsoft Office 365. So we think that the world is changing, topology has changed from the mono system to the hybrid world. However, we still are suffering some challenges this year, like I showed here. So the hybrid environment is not an easy way to manage and to construct, actually. For example, people are talking about cloud connection. So people might say, as long as we deploy virtual software, like which is U1 appliance into the cloud, we can connect to the cloud. That's true. However, assume that we have a hybrid environment, like I showed here. Assume that we have N cloud environment and we have N branches, for example. So in this case, we might need N cloud CPEs and even double one link for the cloud. And more overlay tunnels are necessary here. However, even we consider about the VNFs, so to deploy it into the cloud. Just think about if we have lots of cloud environment. We might need lots of VNFs like firewall optimization deployed according to each cloud environment. So this will create very huge complexity and opacity here. So the next challenge that we are facing with is the security. So because, just like I mentioned at the beginning, we see the increasing use of the internet and public cloud. So many new traffic pattern occurs here. For example, as shown here. So we see lots of more and more local breakout traffic, just like many SD-WAN vendors said. To local breakout internet traffic will improve performance. And also, as I mentioned in the beginning, we see more and more remote access traffic. People work from home, they access to the internet, they also access from the internet to the internal enterprise network. So we need a kind of secure gateway, to handle such traffic pattern. So this is one case. Another case is the increasing usage of cloud. So just like I mentioned at the beginning, now we are entering the multiple cloud world. So some new pattern, like more and more, we see more and more traffic exchanging between private network, MPLS, and the cloud, the public cloud. And also, we see the increasing traffic among the public cloud, like traffic between AWS and Azure. So I think because different network, different cloud, even within the company, was managed by different group company or different divisions inside the company. So we might need a kind of final policy control, access control for the cloud access here. Last but not least is the performance. Because people are saying that we don't need MPLS, we don't need on-premise server anymore. We will move to the SaaS, we move to the cloud. However, I think most of the cloud and SaaS application is based on the internet. So here, we are experiencing some performance issue. So on the left picture, it shows a very typical enterprise deployment. So all the internet traffic will go via their headquarters and will go via the centralized proxies on their headquarters. So what's the problem? So they might experience the occurrence of helping, like here. They can break out, but they go a long way, so which increase the latency here. And also, Office 365 or SaaS application, they often create a lot of sessions, which actually creates a huge burden on the existing proxy. So this is another bottleneck here. So also let's look at the other side. So why not? Some people might say, why not we local break out any traffic? So this comes to another issue. So is really internet connection reliable, stable enough to handle business case? So here I listed two factors that we have to think about. So the first one is in Japan or in some developed country, the internet traffic, the internet is good enough, to handle some cases. But it's not the case for all the countries. So some developed countries, they don't have, very good internet environment. So this is one case. Another case is that, let's think about long distance communication. So we cannot control the underlay. So, the ISP, inter-ISP routing changes every day due to the policy. So sometimes we go go a far place, which causes latency here. So what I want to mention here that, performance might be the issue even if we offload our traffic to the internet. So here comes to our strength. So as a global carrier, so what we can do to help the customer solve such issues, which I mentioned. So first of all, we have a very stable global networks on both the public side and private side. We have public IP backbone where the tier 1 ISPs we have the global network, and also for private network, we have a very good reachability. And moreover, here, so a little different from the SaaS provider or cloud provider. So we have the strengths on the last 1 mile. We have the control of the CPE. So why not use that strength to provide value-added service to the customer? So also, this is another strength that we have. So we have the global-wide POPs of data centers and clouds. So on the left, we have global scale data centers. So this is just one example of the picture. And moreover, we have the cloud services that scattered all around the world. So why not use the strengths of network and cloud infrastructures to create more values to the customer here. So this slide shows the main topic of my talk today. So actually, we are developing a new NFV platform. So this is the concept. So let me explain a little bit about what is behind it. So first of all, we have just like I mentioned, we have a global scale data center. So the NFV platform is scattered all over the world. So every place the people can use this infrastructure. And also, people can access this infrastructure via multiple access approach. Like people can access via LTE, people access via internet, and also the existing business. So no limitation on the last 1 mile. And also, we provide value-added services here. So like VNF, such as one optimization firewall, can be deployed on the edge here. And moreover, not only on the edge, also on the UCP. Just, many people talk about UCP in this conference, so we are doing the same thing. So we deploy value-added services here onto the UCPs as well. So this is another point. And also, our platform has the direct connection to the cloud service. We have private connection to the cloud provider like Amazon and Azure. And also, we provide public peering with a SaaS provider like Microsoft Office, Microsoft Network, for example. And last but not least, we have like I mentioned in the beginning, we have a very solid network, underlay network. So we utilize this network to connecting all of the VNF backgrounds so that they can communicate with each other. So this is the blueprint of our concept behind. So in this slide, I would like to present some potential use cases that can, the value-added service that we can have by utilizing this infrastructure. So first of all, as I mentioned here, we have the cloud connection, private connection to different cloud, including Amazon and Azure. So in this way, we can provide cloud connection in one point. So this is one point here. And also, like I mentioned in the beginning, just now, so we have a direct pairing with the SaaS provider network, so which can provide guaranteed high speed and security via this direct pairing. And also, VNF, in this example, firewall and WAN optimization deployed in the edge. And also on the other side, we can deploy WAN optimization because we want to achieve end-to-end WAN optimization. So this WAN optimization can be deployed on the customer premises. So why we have to deploy VNF here? For two reasons. So the first reason is I mentioned in the beginning. So we need a finer access between services. We have traffic from cloud to cloud. We have the traffic from MPLS to cloud. So this is just like a hub. So we need security services to do the access control in this hub. And also, by deploying VNF here, we can achieve a kind of aggregation, service aggregation. So if, for example, if we deploy WAN optimization here, when people access from here to Amazon or here to Azure and even here to Sas, so they can use the same infrastructure. They can use the same WAN optimization to reduce the cost. People do not need to deploy the WAN optimization in here, here, here. So just one point, they can accelerate all the services here. And here comes to the next use case. It's the secure internet gateway. So in these use cases, we deployed VNFs, like UTM services, VNFs, onto the carrier edge, which, in the same place that I mentioned here. So in this way, we can provide a kind of, secure internet gateway here. When people access from MPLS to the internet, this is one pattern. And also, when we talk about local breakout by utilizing SD-WAN, we can create a tunnel from SD-WAN to this UTM. So we can provide the UTM for the local breakout traffic.
What is UTM, sorry?
UTM, this is the security, unified security platform.
Just the abbreviation, what does it stand for?
Universal threat.
Sorry.
Also, please, yeah.
Universal threat management.
Yeah, threat management. It's a kind of, unified security services here. Yeah. You can think about it like a firewall or proxy, web proxy, and so on like that. So local breakout from here to here. So we can use this infrastructure. And also for the e-work, like people work outside the company, when they access internet, they can create SSH VPNs to here, and they can still use the same functions here to access internet. And also for cloud also application needs to access the internet, so they can also use this infrastructure. So just one point that provide services to all of the, the access point. And also, inside this infrastructure, we provide kind of service chaining. So people might say that I want Palo Alto, but some people may say I need Fortinet, for example. So we provide a variety of selection and options to the customer. So the customer can choose what kind of VNF they need, just like a kind of marketplace. So then we create service chain for the customer. Then they can use the service chain they can use the VNF. For sure, if they do not need it, they can on demand delete the VNF and create a new VNF and so on. So this is a totally customized approach for providing service to the customer.
Sorry, what is LBO?
What is? LBO, it's a local breakout. I'm sorry. Yeah.
Thank you.
So here comes to just like my title is from concept to the real business. So this is it's a new deployment that we did last week. It's the latest live customer cases that we deployed our infrastructure to Formula One McLaren team. So last week we had a race in Japan. It's a Suzuka Grand Prix. So we deployed this infrastructure to McLaren. So what we deploy to the customer is that we provide NFE infrastructure here, the edge cloud, the UCP to the customer. And also we provide multiple cloud interconnection and direct peering to the customer for their connection to the SaaS, for their connection to the cloud, AWS, Azure, example. And also we deployed SD-WAN on the UCP, WAN optimization on the UCP. So in order to provide the connection and the WAN optimization in this case.
UCP is sitting on this running car there.
No, not on the car, in their garage. Yeah. Yeah. Thank you. So this is the result that this is the latest result that I summarized in this weekend. So what did we achieve? So this picture showed the network that we provide last year. So we provide POP-based optimization last year to McLaren. But what we found is that we have a very good backbone here. Just like I mentioned here, we have more than 100 megabps backbone network. And with one optimization, we might even achieve more bandwidth, more throughput. However, in most cases, in Japan, we can provide 1 giga internet connection, but in most other countries, the limitation is that we only have 20 megabps for the access. So access becomes a bottleneck. Although we do lots of compression, caching in the POP, but we cannot achieve good throughput from the perspective end-to-end. So in this race, we download one optimization from the POP to the CPE. So we achieve a dramatic performance improvement for this. So this is one case. So another case is Sas Optimization. So this picture, I explained it. I just want to skip it here because I don't have enough time. Most of customers, they break out their Sas traffic from their headquarters. The customer is the same. All their Office 365 traffic is sending back to their headquarters in UK, then break out there. And just like I said, they suffer lots of performance issue. So in this POC, we'll provide a kind of local POP-based breakout. We break out traffic in Japan, and also by utilizing the direct pairing with Microsoft, the customer can have a very fast connection to the Microsoft network. So as shown here, so just as one example, we achieve dramatic performance improvement for downloading file. This is just an example from the SharePoint to the garage. Yeah, just in time. Thank you for your attention.